Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into DeepSeek-R1, a groundbreaking large language model from DeepSeek AI. It's really exciting stuff.
I've heard whispers. What makes DeepSeek-R1 so special? Is it just another big language model, or is there something truly innovative here?
Oh, there's definitely something innovative. They've taken a unique approach, focusing heavily on reinforcement learning, RL, without relying on the usual supervised fine-tuning, SFT, as a preliminary step. Think of it like teaching a dog tricks. Instead of showing it exactly what to do, they're rewarding desired behaviors.
So they're training it through trial and error, essentially? That's a bold strategy. What were the results?
Precisely. And the results are impressive. They created DeepSeek-R1 first, trained purely with RL. It showed amazing reasoning abilities, but also some quirks like repetition and language mixings. So they refined the process with DeepSeek-R1, adding a cold start data phase before the RL, addressing those issues.
A cold start phase? Could you elaborate on that a bit? I'm not entirely sure what that means in this context.
Sure. Think of it as giving the model a little initial knowledge base before letting it loose with RL. It's like giving a child some basic building blocks before letting them build a castle. It provides a foundation for better reasoning. DeepSeek-R1 now performs comparably to OpenAI's R1 models across various tasks.
That's a significant achievement. But they didn't stop there, right? I saw something about distilled models.
You're right. They also distilled DeepSeek-R1 into smaller, more efficient models. These distilled models, based on Llama and Qwen, surprisingly outperform OpenAI's On-1 Mini across several benchmarks. They've open-sourced these smaller models, making them accessible to the research community. This is a huge contribution.
Amazing! So not only did they create a powerful large language model, but they also made smaller, equally impressive versions available. This democratizes access to advanced reasoning capabilities.
Exactly. And the best part? They've provided comprehensive evaluation results, comparing DeepSeek-R1 and its distilled versions to other top models across various benchmarks like MMLU, DROP, and even Codeforces. The numbers speak for themselves. DeepSeek-R1 consistently performs exceptionally well.
I see. So it's not just about the performance, but also about the transparency and accessibility. They've made the models, the data, and even the code available. That's a huge step forward for the field.
Absolutely. It's a testament to their commitment to open science. They even have a chat website and an OpenAI-compatible API, making DeepSeek-R1 readily available for anyone to use and experiment with. Plus, the licensing is very permissive, allowing for commercial use and derivative works.
One thing I found interesting is their use of a mixture of experts, MO, architecture. Is that a key factor in their success?
That's a great point. The MO architecture is indeed a significant aspect of DeepSeek-V3, the base model for DeepSeek-1. It allows for efficient scaling and specialization, which likely contributes to its strong performance. You can find more details about the architecture in the DeepSeek-V3 repository. It's a bit more complex to explain in detail here, but it's definitely worth exploring further.
Definitely. This has been a fascinating discussion. It seems DeepSeek-R1 represents a significant advancement in large language model technology, both in terms of performance and accessibility. Thanks for breaking it down for us.
My pleasure. And remember, listeners, you can find all the links and resources mentioned in today's episode in the show notes. Until next time, goodbye and happy listening.
Bye-bye.